Okay, problem worksheet 7 is, it's called Working with Rational Expressions, and it is 7 problems where you're doing just that. You're adding, subtracting, multiplying, dividing rational expressions. And I chose to do a video for you here because this is a pretty important skill in the sense that you use it all of the time, and I find that students are a little bit weak on it, so I'm going to make a couple of short videos that will help you. This particular video is focused on exercise 1 in worksheet 7, and just give me a couple minutes to run through some of the things going on this that ought to help you with exercise 1. Exercise 1 is not difficult, and that's because it is a division problem. Multiplication and division of rational expressions is really as easy as it gets. Again, I'm doing this because rational expressions tend to throw students, and for good reason. They are A, fractions, which is not good right there, but B, they've got polynomials in the top of them, so they're not like 3/8, not that kind of fraction. Instead of a 3, they've got a third order polynomial on the top, and instead of an 8, maybe they've got a fourth order polynomial. So they're nasty looking things. But when you're dealing with the arithmetic of fractions and you are multiplying and dividing, it doesn't get any easier. Here's a problem. One rational expression, a second rational expression, that says multiply them together. Guess what you do? You just go ahead and multiply them together. You don't have to find common denominators. You don't have to do anything. Right? You just say 2 times this is sure enough 2 times that, and 5x times 4x minus 18 is just that. Now, it's only good manners to factor out any common factors. So let's do that real quick. If I look at this top expression, I got a 6 and I got a 27. There is an awful lot of 3's running around there. This is 2 times the 3, this is 3 times 3 times 3. So let's take a 3 out, and let's multiply the 3. Let's not do that. Let's just keep the 3x to the 2 here. If I take 3 out of that, I get 2x. If I take 3 out of that, I get 9. I'm not going any lower there. Okay, down below, inside here, I've got a 4 and an 18, so I see a couple of 2's there. This is 2 times 2, this is 2 times 9. Oh, interesting. So I'm going to pull the 2 out. I'm not going to multiply it by the 5 just yet, so there's the 5, here's the 2, here's the x, and what's left over after I take out a 2? 2x minus 9. Okay, so now we're not done, right? We're not done, because now let's look common factors between the top and the bottom. Let me say that again, because this is what students miss. I'm going to slash something here, and that's a very dangerous thing. Anytime you see someone slash something, or more importantly, anytime you slash it, you got to check the following. What you're doing when you're slashing is you are taking a term, a single term, out of every term in the fraction, okay? So you see a 2 up here and a 2 up there. That 2 multiplies every term at the top. There's only one term at the top, right? It's that thing right there all multiplied together. That 2 multiplies every 2 on the bottom. I don't need both of them. Effectively, I can multiply top and bottom by 1/2, and this 1/2 times that 2 turns it into 1. That 1/2 times that 2 turns it into 1. Both of them disappear. We don't have to keep factors of 1 around. And oh, by the way, 1/2 divided by 1/2 is 1. All right, so you can think of it like that if you'd like to. Or, providing there is a 2 in every term, you can slash it. You can effectively divide this 2 into that 2 and get 1. Okay? So I'm not quite done. Right now I've got 3 times this parent, 5x times this parent. Notice that those two parents are the same. Okay, so every factor on the top, i.e. this factor, contains a factor of 2x minus 9. Every factor on the bottom, i.e. this factor, contains a factor of 2x minus 9. Every term on the bottom contains a factor of 2x minus 9. So I can cancel these guys. Okay. Now, I must say, I'm going to do it, but there's really a caveat here. And the caveat really should have appeared back earlier on, okay? Because right up here, remember what a rational function is. It is a polynomial p divided by a polynomial q, with the caveat that q can never be 0. And so that means in this case, x cannot be 0. If it is, the bottom is 0. And x cannot be 18/4, which is 9 halves. Okay, if you put x equals 9 halves in here, you get 4 times 9 halves is 18 minus 18 is 0, and you get 0 on the bottom. The whole thing's undefined. Okay, so given that you have made this, made this statement already, feel free to cancel these. Right? It's no problem. You can cancel them. Without that, I would really want you to say, I'm going to cancel these provided 2x minus 9 does not equal 0. Okay? That's kind of the good way to do it. So at the end of the day, I've canceled everything here. I've got 3 all over 5x. And that's what this problem is. This is the reduction of that problem. Great. So there's problem 1. There's my first shot at a sister to exercise 1. But in fact, exercise 1 is a division problem. Like, I don't know that you think like I do that multiplication and division pretty much the same thing, right? In fact, in order to carry out this division problem, you probably have stuck in the recesses of your mind that you're going to invert this second fraction and multiply. That is, you're going to turn this problem into 5x plus 10. You're going to turn that upside down. You're going to turn the division into multiplication. So I'm not going to take time to explain why those two things are the same, but they are. And now we're back to this problem. We're just multiplying. Let's just multiply the top. Multiplication of fractions is the fun thing to do. Okay, and the second one is right here times 5x plus 10, 20. And now we're going to just do some simplification, right? This time I'm going to do it like this. I see this 4. This 4 goes into this 12, and it gives you a 3. Let's just tick these things off, indicating that I've dealt with them. This x goes into this x squared. Let me kind of get the fraction set up. This x goes into this x squared and leaves me an x down here. Now what have I got? This is a difference of squares. Learn to recognize this. This is x minus 4 times x plus 4. And what's down here? I get a 5x plus 20, which is 4 times 5. So I'm going to factor out a 5, and I'm going to be left with x plus 4. Okay, I'm almost done here. I've got a 3 up here, but that's the only 3. I've got an x, that's the only x. You cannot divide that x into that x. You can't do it, because remember, if I'm going to divide out or cross out or slash out this x has to appear standing by itself as a factor in every term. There's one term here. There are no singular x's. So you cannot take that x out of that term. You cannot do it. If you were to divide an x out of the bottom, if you were to multiply this by 1 over x, 1 over x, this x would divide into this x. This 1 over x would divide into this x and give you 1. But this 1 over x would just make a mess. For instance, it would divide into this term and give you x into x is 1 plus 4 over x. That's what would happen if you were to try to divide x out of this. You cannot just go slashing x's. If you do not understand that, seek help. And I will guarantee you some of you don't understand that. Okay, I'm about ready to take this common factor x plus 4 and this common factor x plus 4 out. But remember, before I do, I'm going to come back over here and say, you know what? In this particular problem right here, this is what I should be pointing at. right? X cannot be equal to minus 4, because if it is, 5 times minus 4 plus 20 is 0, puts 0 in the bottom. And it cannot be equal to 0 either, because that makes this whole term 0, and you'd be dividing by 0. Okay, so that covers the situation we're in right now. I've got a 0 in the denominator. I've got an x plus 4 in the denominator. Sure enough, x cannot be 0, or this whole thing is undefined. X can't be minus 4, this whole thing is undefined. So given those properties, given that this factor is not 0, I'm going to go ahead and cancel it. Oh, and I probably got too low there on the page. Let me do that again. 3x minus 4 all over 5x. Okay, I'm going to come back and do one more of these exercises, one or two more of these associated with this worksheet 7.